My name is Taha Shaffa, and I am submitting Lab 4. I am doing a homogeneous transformation matrix using the shortcut method for an articulated manipulator. This is the diagram for an articulated manipulator. So as you can see, the x3 on the x0 is a 1, 1. And then the y3 is a 1 in the z0 direction, and the z3 is going in the opposite direction of y0. So let's look at what I got from my code. This bottom portion is what I ended up getting for my homogeneous transformation matrices. As you can see, the x is at 1, the y is at 1 compared to the z0, and then the z3 is at -1 compared to y0. So all that checks out. Now you can see the displacement vector says it's 2 in the x direction, 0 in the y, and 1 in the z direction. So now if we were to look back at this diagram, you can see that indeed in the z0 direction does go up by 1, and then the x direction, it goes to the right by a2 and a3, and each of these a1, a2, a3 values I put as 1, similar to the way that you did in the lab. So again, that checks out as well. You have 1 plus 1 equals 2, y is at 0, and then z is at 1. So I believe this is actually a correct homogeneous transformation matrix for the articulated manipulator using the shortcut method.